So today's presentations, our project's title is Hydrocarbon Potential Delination using Poisson Ratio Reflectivity. The group member for this project is myself, Ibrahim Muharram, and Muhammad Ali Akra bin Arman. A brief description about this assignment is acoustic impedance and shear impedance are commonly used to delineate hydrocarbon instead of Poisson impedance. Poisson impedance is also important and can be used to delineate hydrocarbon. Bright spot is typically determined by the products of intersect and gradient. Hydrocarbon presence can be detected using Poisson's ratio RBO attribute. The objective is to delineate hydrocarbon cluster based on cross-plotting of selected log data, and the second is to analyze characteristics of hydrocarbon indicator using scale Poisson ratio chain. The methodology for this project is by using HRS. First, the fluid replacing model. The parameter is reservoir intervals, velocity, density, in situ fluid. The objective is to manipulate well log and to perform Gassman fluid substitutions. Second, the elastic properties, which is the parameter, density, P impedance, S impedance, Vp over Vs ratio, Poisson ratio, and lambda rho. The objective is to calculate the elastic properties for each fluid type and display the cross plot. Next is ABO modeling. Parameters for ABO modeling is seismic wavelet, seismic geometry, depth to time conversions, and the objective is to create synthetic seismogram. And lastly is ABO analysis on 2D data. Objective is to perform ABO analysis on real CDP gather. This is the workflow for this project. First, fluid displacement modeling, and then we generate well log for Poisson ratio, P impedance, S impedance, rho, and resistivity. Next, we generate cross plot. After that, we extract wavelet from the seismic data, followed by creating synthetic seismic data, and lastly, we perform AVO analysis. This is the result. The graph shows is gamma ray vs Poisson ratio. The Poisson ratio range for gas is from 0.07 to 0.18, while for oil is 0.23 to 0.30 and brine 0.30 to 0.34. Gamma ray range from 30 to 80 API for all fluid types. Shear line is strongly formed vertically at 95 API. Points are sparsely distributed, distinguishing based on the approximately formed points. Difficulty in delineating polygons for oil saturated is indeterministic area boundary, and for brine saturated are points mixed with shale. Next, the graph shown Poisson ratio with SP impedance. Poisson ratio range for gas is 0.08 to 0.18, while for oil is 0.26 to 0.30 and brine 0.32 to 0.40. The impedance range for gas, oil, and brines are the same, which is within 4,700 to 6,500. Points are aligned and parallel to shear lines. Polygons are evenly spaced and shift in the stackings toward right. This shown a significant hydrocarbon delineations. That's all for my part. I pass the floor to Ani Akra to explain more about the graph produced from this project.
Hello, my name is Muhammad Ani Akra. I will continue the presentation on the result of cross plot. In this slide, we can see the cross plot of Poisson ratio versus S impedance, and we can see the delineation of fluid type, which are gas in the red polygon, oil is in green polygon, and brine is in blue polygon. So the cross plot show that the points are parallel to the straight line, and the polygon are evenly spaced and stacked horizontally. It also shows significant hydrocarbon delineation. Next is cross plot of Poisson ratio versus Vp over Vs, and we can see here the points are aligned along an inclining curve line. At the top blue one is brine, and below in green is oil, and in red is gas zone. The polygons are closely formed along the curve. This cross plot can also be used as a sequential hydrocarbon delineation. Then we move on to the density versus Poisson ratio cross plot. The cross plot showed that the shale line is formed horizontally at 2.28 gram per cc. The thing that we can identify is the behavior of the point with increasing Poisson ratio. As you can see, gas zone is tied to sparse. For oil, is tied to linear, and brine linear to sparse. It can be used as a reliable hydrocarbon delineation. Then the last cross plot between resistivity versus Poisson ratio. In this cross plot is a bit different because the resistivity range from 6 to 12 ohm meter for all fluid type. The shale line, as you can see in the cross plot, is formed vertically with poor delineation. The points are sparsely distributed and need to be distinguished by proximate point. Now we move on to the discussion. Based on the relationship of various cross plots, the results show typical behavior of form for all the cross plots, which is gas sand are plotted far from the shale line, followed by oil and brine. And based on the cross plot, there are cross plots with good hydrocarbon delineation, such as Poisson ratio versus P impedance, Poisson ratio versus S impedance, Poisson ratio versus Vp over Vs, and last one is density versus Poisson ratio. But for gamma ray versus Poisson ratio and resistivity versus Poisson ratio have poor delineation of hydrocarbon. As conclusion, based on the AVO analysis, based on the scale Poisson ratio change, in the highlighted area shown that the Poisson ratio for the gas sand show negative value based on the Poisson ratio scale over here. Both upper and lower shale show positive value of Poisson ratio scale. The transitioning from the shale to sand show decrease in Poisson ratio reading. This is because gas sand has low Poisson ratio. So it is conclude that Poisson ratio reflectivity can be used to delineate hydrocarbon. That is all for our presentation. Thank you.